All right, so let's go ahead and start our unit 5. We're going to be talking about bonding, but before that, we need to be talking about electrons. We need to be able to describe them. We need to understand what they're doing in an atom before we can get into the bonding that we get in chemical bonds. So let's go ahead and start with quantum theory. I know it sounds like a very fancy term, and so this is usually what people will use when they're trying to sound very smart, very sciencey. Something like according to quantum mechanics, according to quantum theory, or maybe you've seen sci-fi shows like Quantum Leap. They talk a lot about this quantum a lot. So what is it? What is it that we're talking about? So if you look it up on Wikipedia, a quantum is just more of a general term, and it's according to Wikipedia, it's just that it is the minimum amount of any physical entity involved in an interaction. Now, some of those words were a little bit big, so just to demystify that a little bit and make it a little bit more simple, we focus on things that are very small. And so we've been talking about the atomic theory. We know that all of matter is made up of atoms. It's the smallest piece of matter that we can break it down to before we get into the subatomic particles that don't really have the properties of matter. So we'll be focusing on the atoms still. And so when we talk about quantum theory, we're really talking more about atoms. And more specifically, we're talking about electrons. So we can use this quantum theory to both describe and predict how electrons work, what they do in an atom, and how they fit together with other things. All right, so just a quick warning is that we're not going to get too in depth into quantum theory for this video, but just know that when we're looking at quantum stuff, things get very weird. You have to adopt a whole new way of thinking because we're not used to thinking in this way. So when it comes to quantum theory, we're dealing with a lot of probabilities. We can't know anything for sure, and sometimes the best answer that we can come up with is just maybe this is what's happening, maybe this is what we can see. And so just keep in mind that when we're talking about things that are very, very small, things get very, very weird. All right, so let's review a little bit because we've seen Bohr's model of the atom. We know what this looks like, and the basic structure of it is that we have the nucleus of an atom in the center, and then we have these rings around it where we draw in our electrons. And so this, I've told you this before, that it's a very practical way to think of it, very practical way to write it. But the truth of it is that it's just a simplification to make things a little bit easier on us. The reality is little bit more complicated than that. Technically, it's not correct, but practically it is correct. But let's look at what technically it is correct. So electrons, they don't follow these rings, right? So if you can think of this kind of like a train track and the electrons being trains, the train can only go in the places where there's a train track. And so that's the same thing that we're showing with the electrons, that they can only be found on this ring. But the reality of it is that they're found all over the atom, sorry, all over surrounding the atom, but they are always in constant motion. They can always move to another place, and so there are just regions where we usually find electrons, and there's other regions where it's a little bit less common. So if you look at this density map right here, we can see that we have all these possible locations for the electron. We have the nucleus at the very center, and you can see that it's a lot more concentrated near the center than it is towards the outside. And so what we're doing for our functions of probability is that we're just uh, creating this boundary or this ring around the atom, and we're approximating that that's where we'll probably find the electron with a fair degree of certainty. So this is where we get our boundaries. This is really more just like an average of the areas where we find the electrons at any one time. And so now it's just one orbital that we see. The truth of it is that orbitals get a little bit more complicated, and they have a lot more shapes depending on what element we're talking about, how many protons, how many electrons they have, and we'll be looking at some of these in a little bit more detail here coming up in just a second. But first, we have to talk about the Heisenberg uncertainty principle. Again, this is one of those really sciencey terms. You sound really smart when you talk about it because most people don't know what it is. All right, so when we're talking about the Heisenberg uncertainty principle, it's just a fundamental idea that we can never know two things about an electron, both its velocity and its location. We can't know it at the same time. We can only know one or the other. And so let's think of it this way. If we were looking at a car, if it was speeding down the highway, it was doing, I don't know, 70, 80, 90 miles an hour. And for just 1 second, we take a photo of it. Well, you can think of that as sort of like stopping time. The moment that we take this photo, we are stopping time, everything around it, and we are looking just at this photo. Um, in that moment, the car is not moving, and because it's not moving, it doesn't have a speed. But we do know its location. We've taken a picture of the car. We know exactly where it is, so we know its exact location. But since it's not moving in the photo when we stop time, we can't know the speed. We can't calculate it. We can't see it in motion as opposed to let's say that this was instead a video and we could see the car speeding along the highway. Again, we could use a speedometer, we can calculate the distance it travels over time, and we can get its speed for that. But the thing about that is that car is constantly in motion. It's always changing places. So when we focus on a single location, well, after a moment the car's not there anymore, it's moved forward. So for that reason, we can know the speed of an object as it's changing its position, but because it's changing position, we can't know its exact position. And I got really worried, but again, this goes back to the Heisenberg uncertainty principle. We can know either the location or the speed of an object, in this case, an electron, but we can never know both at the same time because these two properties don't match together. And so, to tie in that example, is that in an atom, the electrons are in constant motion, they're always moving around, and this is why we can never know that both location and speed. All right, finally, we get into the atomic orbitals. These are really just a way to organize the electrons where we can find them and where different types of electrons reside. And so we know about the energy levels. This is the overall region of space or the distance from the nucleus where we usually find the electron. So that was the density map that I showed you earlier. And when we're drawing the rings around our atoms, these are the energy levels. But those energy levels, we can um, classify them. We can give them more specific shapes where we can find different types of electrons. And so it's that other graphic that I showed you where we have these different shapes for different orbitals. And so these could actually all be from the same energy level, and they're all taking up the same space at the same time, just a slightly different section of it. All right. And they have very interesting shapes. And what we'll see later sections when we're actually talking about the electron configuration and where electrons go is that each sublevel can only hold 2 electrons at the most. So it's just a matter of being able to manage our space and putting our electrons in the right places where we have open seats, where we have open space to put our electrons. So again, that'll be more for the second section in this. We'll be talking more about electron configuration, how to set it up, and how we can keep track of all our different electrons.